Hello everyone and welcome back to our channel. In this video we are going to have a checkup exercise number 5 on triangles, Pythagoras, congruency and similarity. We have already introduced these 4 topics in our previous video, so if you haven't watched them, please I recommend that you go and watch them first before you attempt this checkup exercise with us. So let's go straight into it. For our first question, we have solve for the unknowns. So our unknowns are x and y. So solve for x and y. Looking at this triangle, you could pause and then try to figure out the answer or work out the answer and then unpause the video to check if your answer is correct. So I'm just going to go straight into it. Looking at this triangle, we can see that we have an isosceles triangle, and if you recall, we said an isosceles triangle is a triangle that has two sides equal, and the angles opposite those two sides which are equal to each other. So this angle will be equal to that angle. So let me just make it clear for everyone. So that means this angle right there will be equal to that angle. So looking at triangle PNO in this green sketch, we can see that we have NO, which is one of our equal sides. So let's highlight that so that we can see what we're working with. NO is an equal side to PO, meaning that they are equal to each other. Why do we say that? Because they have the same number of lines on those lines. So they each have one line on it or one stroke on it. So an isosceles triangle says that if two sides are equal, then the two opposite angles are equal to each other. So these two opposite angles are equal. So if that one is x or n is x, let's say let y be x also, because so let y be x. So let's write that, or let's see how we do that with writing it down. So we have, because let's write it down, because PON is okay, sorry about that, is an isosceles triangle. That means x is equals to y. So we're going to say let x or let y equals x. So we've just said let this y here equals x because it's equal, because PON is an isosceles triangle. Then we're going to say x plus 36 is going to give us 180 degrees. So 180, and I don't have the degree sign, so I'm just going to write it in full. So 180 degrees y, sum of angles in a triangle. That's our reason. Then we move on to solving for x, because we only have one unknown, which is x. So 2x plus 36 is equals to 180 degrees. And if we make 2x subject of the formula, so we make 2x on one side and then we take 36 over, so it's going to be 180 minus 36, which is 144. And if we divide 144 by 2, you get 72. So our x is 72 degrees. And we've just said x is equals to y. That means our y is also 72 degrees. And let's double check if we are correct. So let's just edit our sketch or our figure by entering the degrees that we just got. So 72 degrees, 72 degrees. So let's add 72 plus 72 together. We get 144, right? 72 plus 72 together, we get 144 plus 36, which is the other angle right there, we get 180, meaning that's correct because all angles in a triangle always add up to 180. So we have solved x and y correctly. Let's move on to the next frame or slide. So in this one, we are given 30 and 60, and looking at this, we can see that we have an exterior angle, and exterior angle says that the exterior angle, which is this angle x, is equals to the two interior angles added together, so is equal to the sum of the two opposite interior angles, and the opposite interior angles are these two. So if you add them together, you should get x. So if you add those together, you should get x. So you add those together, you get x. So let's write it down and see how we would write it mathematically. So sorry about that. So we have 30 plus 68 is equals to x, y, exterior angle of a triangle, and let's name our triangle. That's good practice. So NPO, that's our triangle. So we solve for x. So 30 plus 68 is going to be equals to 98. So x is equals to 98 degrees. 98 degrees. And if you haven't watched the video on exterior angles of a triangle, please go and watch it. It's in the same playlist, Euclidean Geometry playlist on our channel. Let's move on to the next question. So we've already answered the question. It says solve for x, and x is an exterior angle of triangle NPO. So we are going to move on to our next question, which is solve for x, and we are given that NO is a hypotenuse. So NO, which is our x, is the hypotenuse. And we know that for us to have a hypotenuse, there should be a 90 degree. And where should the 90 degree be? It should be at the opposite angle of the side, to the side. So using the arrow in the picture so that you can see what we're talking about. The hypotenuse is NO, right? And the angle is always going to be opposite, the angle opposite the hypotenuse. So that's how you'd write it. So let's quickly just draw a nice 90 degree and hypotenuse right there. So we know that we have a 90 degree, and if we have a 90 degree, we are free to use Pythagorean theorem. So let's use it and see what we get for hypotenuse, or what we see for x. So if we were to write it down, we would say the following. So we just make that bigger. We'll have x squared. So x squared is equals to 15 squared plus, so 15 squared plus 20 squared, and that will give us our x squared, which is, so let's simplify, 20 squared is 400 plus, and so we get 225. So 225 for 15 squared. So 15 squared is 225 and 20 squared is 400. And if you add those together, so 225 or 225 plus 400 is equals to 625. And that's our x squared. So let's just do that so that we can see what we're doing. And so if we, that's x squared, but we want x, so x is going to be the square root of 625, which is equals to 25. Sorry. So our x in this case is equals to 25. So our hypotenuse is 25 units. And that's how you use Pythagoras. In this case, we're not given the 90 degree, but we're given that the sketch had a hypotenuse, or one side was a hypotenuse. And that's how we got to know that there's a 90 degree, and then we got to use Pythagoras. But you can never use Pythagoras without a 90 degree. You have to be sure that there's a 90 degree to be able to use Pythagoras theorem. So let's get it. And let me just show you how you check when your answer, if your answer is correct or not. So let's say they did not give us this 20, or let's choose 20. Yeah, let's say they did not give us this 20, so it's not there, and that's our x. That's, let's say y, so that we don't get confused. Y, and we are given the hypotenuse to be 25. So we want to check if 25 is correct. We want to check if we use Pythagoras with 15 and 25, will we get 20 right there? So let's do that real quick. I think I'm just gonna remove all this, or just write it below. So we're going to have, let me just change the color to red since we're working with red values this time around. So we are going to say or we're just going to say 25 squared because that's our hypotenuse. So 25 squared is equals to 15 squared plus y squared, because we don't know what y is. And then we're going to solve it. So 25 squared is 625. If you use your calculator, you get 625. 15 squared is 225. And our y squared remains y squared because we don't know what y squared is. That's our unknown. And if we want to make y squared stay on our right, and we take 225 to get 625 because they're like terms, we say 625 minus 225 and we get 400. So 400 is equals to y squared. But we don't want y squared, we want y. So how do we get y? We square root the 400. So it's going to be square root of 400. And that is, if you use a calculator, you get 20. So that means, so let's move on to the next question. So we have solve for x once again. And as we can see, our x is there. Our x is in the triangle DBC. And we can see that in triangle DBC, we have a 90 degrees, so we can use Pythagoras. But you know Pythagoras needs at least two sides to get the other side. But looking at this triangle, we can see that DBC has only one side's length. The other sides don't have a length, like BD doesn't have a length, and DC doesn't have a length. It has X, and X is still an unknown, so it does not have a length. So we are asked to get X, but we don't have the other side, DB. So how do we get DB? So those are the kind of questions you should ask yourself when you're trying to solve such a problem. So how do we get DB? And we can see that DB is also a line, or actually the hypotenuse of triangle BDA. So that's the hypotenuse of triangle BDA. So let's mark it H for hypotenuse, the side. So let's get hypotenuse in BD. Then we work with that hypotenuse because the same side in triangle BDC to get X. So let's see how we write that mathematically. So we start off by stating that we start off by saying in triangle ABD, so ABD, let's state, so we have a hypotenuse. We can just start off by saying H squared plus, it's actually equals to 4 squared plus 3 squared. And our reason would be, so you always have to have a reason, I'm just going to say Pythagoras theorem. And then our H squared remains H squared because it's an unknown. And 4 squared is 16 plus 3 squared is 9. So plus 9 is equals to 25. And if you take the square root of, so let's say H squared is equals to square root of 25. And we get our answer to be 5. So our H is 5. And so let's go back to our sketch and we quickly write that down. So that is 5. So that is 5, and let's just write that down, ignore them. So now with that we have 5 and we have 13, and this is a right angle triangle. We can use Pythagoras to get X. And so we're going to use a green color so that we can show that we are now working. Okay, let's use another color because it's going to be camouflaged. Let's use red, a brighter red. So that was maroon, now we're using red. So we're going to say 13 squared because that's the hypotenuse. can you see, how did we say this one was the hypotenuse? Because the angle, the 90-degree angle, is opposite the side. In this case, the 90-degree at D is opposite 13. So that's 13 is our hypotenuse. So we always start with the hypotenuse is equals to one side, which is 5 squared, plus the other side, in this case, which is x squared, which is our unknown, and we solve the problem. So 13 squared is equals to 169, is equals to 5 squared is 25, and we have that x squared is x squared because it's an unknown. And so once to solve for x, so we're going to put x squared on one side, and that is going to be x squared, or let's keep it on our right hand side. So 169 minus 25 should be 144. Yes, so it's 144 is equals to x squared. And if we x squared, so let's put x squared this side and just say square root of x. So x is equals to square root of 144, and it's square root of 124 is equals to 12. And so that's our x. And can you see how we got it? We looked at where x is. So x was at DC, line DC, and we asked ourselves, so what do we need to get x? X is in a triangle that is a right angle triangle, right? So DBC is a right angle triangle. So we can use Pythagoras. What does Pythagoras mean? Means we need a hypotenuse and two other sides. So a hypotenuse, so we need two sides to work with Pythagoras. And we saw that we only had the hypotenuse and we did not have the other side, but we had x, which is the unknown. So we looked at this side of the triangle and we asked ourselves, how can we get BD? And we saw that BD belongs to another triangle, which is a right angle triangle, and that right angle triangle has two sides, so we could use Pythagoras to get the hypotenuse in that triangle and then worked back to get x. And so that's how you do it. Let's see if we have more questions in store for us. And yes, we do. 2 more questions, by the way. So let's look at this one, and it says solve for x. Solve for x. And we can see that x is right there. So let's just circle our x so that we can see where it is. Right there. And so what do we need to solve for x? Looking at this and looking at the knowledge that we have already been given, we can see that the triangle we need to work with here is triangle ABD. So this huge triangle that I've just highlighted. So that's the triangle we need to work with. So we can see that we already have that side. We already have that side. And so we can get that side using this whole side using Pythagoras theorem. So let's do that right now. So that would be the hypotenuse in this case, because let's just show you how we get the hypotenuse. The hypotenuse is the side that is opposite the 90-degree angle. So we're going to say 30 squared. 30 squared is equals to the one side, which is 24 squared, plus the unknown. So let's call this whole BD. So from B to D, we are going to call it y. So plus y squared is equals to 30 squared. And so we are going to solve it and say 30 squared is 900. So let's fill that in. And we know that 24 squared is 576, and you can use your calculator for that, plus y squared. And we make y, so we need y, because y is the distance BD. So we're going to say 900 minus 576, and we get the answer to be 324. And that is equals to y squared. So y itself, so we're going to square root that 324 to get y. So y is going to be equals to 18. So y is equals to 18. That means this whole part here, this whole part from B to D is 18. Now how? So I was thinking, if we have 18 and we can get this part here, then we just say 18 minus the blue. So the yellow minus blue will give us x. I don't know if you get it. So let me just explain what I mean by that. So let's say we have a line, and I've just told you that the distance from there to there is 20. And I tell you that, but that line is cut, and this side of the line is 15. So this side of the line is 15. What is this side? This side is x. And that's the exact same thing we have in this sketch here. So how do we get x? We say 20 minus 5 is 5. 20 minus 15 is 5. And we can see by saying 15 plus 5 we get 20. So this 15 here plus that 5 there will get 20. So that's what we are using. That's the logic we are using in this case to get x. So how do we get the blue part in this green sketch? We'll get it because we can use the triangle. So the smaller triangle, which is triangle, we just use a different color. So triangle ABC. So triangle ABC will help us get our x, or the distance in blue. So let's write that, and we are going to get, so we're going to write it here. And so it's going to be, so our hypotenuse in this case is 26. So 26 squared is equals to 24 squared plus the blue part, let's call it m squared. And we see that 26 squared is 676. 676 is equals to 24 squared is 576 plus m squared. And if we make m squared the subject of the formula, we're going to say 676 minus 576 is 100. And so our m is equals to 10, because square root of 100 is 10. So our m is going to be equals to 10. And so our m is the blue part in this case. So our m is this blue part. So let's quickly fill it in. So that is our m, and it's equals to 10. So if we have 10 and we say the whole distance there is 18, then we're going to say 18 minus 10 is 8. So our x is equals to 8. So let's write that down. So we said BD. So I want you to just have a look at what we're writing here so that you understand the concept better. So we are saying BD. Look at line BD. BD is equals to BC. Can you see that BC? We add BC plus CD to get BD. And we say that BD is 18. So let's substitute 18 for BD. And we say that BC, we just got BC, and it's the blue. We said it's 10. We don't know CD because that's x. And they want us to get x. So we'll say 18 minus 10, which is 8. 8 units. So our x is 8 units. And that's how you solve for x in this case. So you always have to look at where x is. What can I do to get that x? Using the information or the theories and topics you have discussed, how can I get x? So let's move on to the next question, and I think that's our last question. Solve for x and y. Looking at this, let's decide which one is the easiest one to solve. And in this case, I would say x, because x is in a triangle that is 90 degrees. And we can see that 15 there is the hypotenuse in this case. And in the other triangle, which is PN or OPN, triangle OPN, we can see that y is the hypotenuse. So let's look at each triangle differently. We are going to mark our triangle PNO with a red marker. So we can see that we have a 90-degree, yes, and that means we can use Pythagoras. But we can't use Pythagoras if we have two unknown angles. We need to have at least two sides to use Pythagoras. So we can't start with a triangle because we don't have enough information. So let's now look at our triangle NRO. So NRO. And we can see that we have one side and we have the other side, which is the hypotenuse. We don't have x. So if we can get x, then in this triangle PNO, we are going to have 5 and that x. So that means we can get y, which is our hypotenuse in that case. So let's write it down and see how you go about solving for this problem. I'm so sorry I have to write on top of the letters. Yeah. So we're gonna start. So we're gonna say in triangle. I think I'm gonna write it on the next page and just keep going back and forth. So we're going to say in triangle. Let's make that as big as possible. In triangle, let's look at this triangle NRO. So in triangle NRO, we have that. What's our hypotenuse? Our hypotenuse is 15 squared. 15 squared is equals to, so 15 squared is equals to this plus that. So this squared plus that squared. So x squared plus 9 squared. So we can write that. So x squared plus 9 squared gives us 15 squared. And let's solve that. So 15 squared is equals to 225. We already figured that out in the previous slides. X squared remains x squared. So x squared remains x squared, and 9 squared is 81. So that's 81. And if we were to make x squared the subject of the formula, we'll have to take 81 the other side, and that's 225, and it becomes a minus. So minus 81. That is 144. And we have that x squared is equals to 144. But x alone is the square root of 144, which is 12. So that's our x in